All right. Hello, everyone, and welcome to today's webinar. My name is Carlo Bobilas, and I'll be your moderator for this session. I'm pleased to introduce today's speaker, Technical Marketing Engineer Karthik Kumar Tatikonda. But before I hand over the mic, I do have a few housekeeping items to cover about today's session. Today's session will be recorded and made available on demand. We'll make sure to provide some details at the end. Also, we'd love to hear from you during today's presentation. So if you are on WebEx and have a question for our speaker, please feel free to send it through the WebEx question and answer panel, where our wonderful panelists are ready to respond. For those tuning into our live stream, we thank you very much for joining in as well. However, Q&A is limited to those via WebEx. Don't fret, we do have a post-event Q&A thread on the Cisco Learning Network community where you can post any follow-up questions you may have. So without any further ado, I'd like to kick things off by welcoming Karthik. Karthik, over to you.
Thank you, Carlo. Hi, everyone. Whichever time zone you are, welcome to this session about Enhanced App Route Tracker for Layer 7 Health Check, tracking Secure Internet Gateway or Security Services Edge Tunnel Health. This capability will be released as part of the SD-WAN 20.14 or 17.14 version of the software code. My name is Karthik, and I'm a technical marketing engineer for the Catalyst SD-WAN product. Bit of a housekeeping here. From 20.12, you would see that the old names are rebranded as shown here, and this is for your information as a reference. I will be calling out new names for the rest of the presentation. We'll go over the agenda at a high level. I will first try to introduce the broader picture in terms of the Catalyst SD-WAN security portfolio. Then I'll talk about the use case for the cloud-based security. And then I will go into the feature overview. I will then dive deep into the solution details, how the feature is going to be helping you, and how do you configure it, and how do you verify it. Finally, I will also talk about guidelines and limitations. I plan to also show you a live demonstration and a recorded demo. And with that, I'll hop on to my manager and show you the key pieces, how to configure things, and then also show you the demo. If you look at Catalyst SD-WAN security portfolio, it provides complete comprehensive solution for all the market segments ranging from healthcare, retail, and government and finance sectors. And we are able to offer different options for your user traffic from your branch or campus, all the to the private applications that could be sitting over on the right side, private data center, or it could be on the private cloud. We're able to also provide access, secure access to your applications that are hosted on public internet, like SaaS applications. By virtue of connecting this, we also provide four key principles. We provide flexible deployment options. You could have your Catalyst SD-WAN security on a SD-WAN edge hardware device, on a physical device, or on a virtual form factor. And you can do security inspection either on the box, on premise, or you can redirect the traffic to the cloud security provider and then enforce security inspection there. The focus of this session will be the use case where we are going to provide security to the cloud security providers, and then how that tracker or the enhanced app route tracker helps in that use case. The second key principle is Catalyst SD-WAN solution allows you to segment your network easily by using VPNs, virtual private networks, or VRFs traditionally. And we can also enforce security policy based on not just the phi tuple, but also using the identity, user information, user group, and security group tags or scalable group tag SGTs. We can also provide advanced security inspection using on-box security capabilities like next-gen firewall on the Catalyst SD-WAN edge. We can do inspection like IPS, advanced malware inspection, TLS for decrypting the encrypted traffic. And we can also complement that with cloud-based security using the cloud security provider and use CASB and DLP and other functions on the cloud. And the final principle is being able to provide visibility on giving the SecOps view on the Catalyst SD-WAN manager and being able to show how the rules, what traffic is subjected to inspection and what are the rules that are being visible on the dashboard. That's also one of the key aspect we provide for the customers. Today's use case, as I indicated earlier, is how do we provide secure direct access to internet or cloud applications? Organizations have scenarios where they have their SD-WAN edge devices that are deployed in ATM sites, or like if it is a bank or it is like a gas station, like retail outlets. We have seen like smaller SD-WAN edge devices deployed in these locations, and they might not have enough memory and compute to run the full next-gen firewall Catalyst SD-WAN security on the box. However, they are still required to access these internet or SaaS application on the right side securely. So we provide as a network administrator for Catalyst SD-WAN, we can dictate the interesting traffic and subject that traffic to go through the cloud security providers using the secure IPsec or GRE based tunnels to these cloud providers. And all the inbound and outbound traffic from internet to these SD-WAN edge devices at the sites can be controlled using the SecOps admin policy set up on these cloud security admin portals. Again, we support a varied number of vendors here. So these are the current list of cloud security providers the Catalyst SD-WAN integrates with. Again, just as an FYI, and what are the supported tunnel types? We provide a deeper integration with Cisco Secure Access on the top and the Zscaler, where we are able to provision automatic tunnels to the cloud security providers. And the rest of the tunnels, rest of the third party providers, you could configure the tunnel configuration on that management portal, and you will be able to establish these secure tunnels to these cloud security providers. Again, this is just for your information. With that, I also want to emphasize that network brownouts are very important for any organization to address this, to provide better user application, and also to improve the employee productivity. If you don't have, if you don't address this, it would also impact the organization revenue. And today's session is going to kind of focus on the use case of providing secure internet access to these applications on the public internet or SaaS applications using the secure tunnels, and how the enhanced app route tracker will monitor for these network degradations and put the traffic into the best performing tunnels. With that, let me give you a brief overview. If you go back to prior to 20.14 or 17.14, I believe on 20.6, we started supporting layer 7 health check. And we were supporting layer 7 health check to monitor the SIG endpoints on these providers. And we were able to send HTTP probes and measure the latency. And then we are providing the best performing tunnel. However, we have seen customers coming back and requesting us to not only support latency, but what about the other network degradation conditions like packet loss and jitter? And this release with enhanced app route tracker, we will monitor the tunnel health on these IPsec or GRE tunnels for packet loss, jitter, and latency. And we'll measure what is the best performing tunnel and put the traffic to the best performing tunnels to these SIG providers or SSE providers. So the solution is the enhanced app route tracker. It provides, again, there are certain key concepts here. I'll talk about them in detail. We have SLA profile, which will decide, what kind of loss, latency, and jitter is going to be accepted on these tunnels. And the system monitors these. And what we will do is we will bring down the tracker down, and then the tunnel will be removed from the forwarding so that the traffic is put on the best performing tunnel. We also support dampening. I'll talk about the dampening as well and the modes. And these are the concepts that I'll cover in detail. And there are some caveats that are listed here for your reference. So when there are tunnels, like 4 tunnels here, so we monitor now, like let's say the tunnel 4 is out of the SLA because it has a loss on this tunnel which is greater than 10%. Now the traffic will be switched over to the best tunnel. Now, in terms of the working details, let's take an example. As a customer, you have configured like your minimum loss is 10% and latency 400 milliseconds and jitter as 30 milliseconds. On the SD-WAN edge device, we send these HTTP probes or samples spaced at every 5 seconds. And what we do is
Hey, Karthik, I think we may have lost audio for a sec. Do apologize. Thank you very much, everyone. Give me one sec while we troubleshoot what may be causing the issue. Okay, Karthik, I see that you're sharing your content once again. However, just to confirm, can you go ahead and say something? Just want to make sure your audio is coming in loud and clear again. I heard something there for a sec. Karthik, do we have you back?
Yeah, I'm here. Sorry about the glitch here. So let me go back a slide. I hope like you saw all these slides, and you guys want me to go back one more slide?
I think you can start at the beginning of this here. So when you started this solution deep dive.
Okay, got it. Okay, let me start from here then. Okay.
Awesome.
Yeah, as a customer, like our user, you would go and configure, let's say, what's your minimum loss accepted on the tunnel, like 10% is the loss that you're accepting. And then your configured latency is 400 milliseconds and the jitter is like 30 milliseconds. What we do is we send a probe, HTTP probe, at every frequency of like this 5 seconds. So each probe will be spaced with 5 seconds of time. And over a period of pole interval, that's what determines the bucket size. And if you look at the bucket size or the pole interval, about like 60 seconds, we'll be able to send 12 samples of probe every 5 seconds. And we calculate the average loss, latency, and jitter at the end of the bucket. And then we compare that to the configured loss, latency, and jitter. If the If we see that the any of the parameter like of all these three conditions, let's say if the loss exceeded to 20%, we bring the tunnel out, like we bring the tracker down, and the tunnel will be out of the forwarding. That means like we have detected a degradation on the network, and that's why we don't want to send the traffic on that tunnel. Instead, it will go to the best performing tunnel. HTTP probe timeout is treated as packet loss. And today, if the probe responds, let's say we send an HTTP probe to the endpoint on the SIG provider, and we get a response, if we get a response within the configured threshold, today, if the threshold is exceeded, the default threshold is 300 milliseconds. If we send a probe and if we don't get the response within 300 milliseconds, that is also considered as packet loss. Latency is measured round trip time, and also jitter is the variation in round trip time. We have a new concept of SLA profile when you have enhanced approach tracker for layer 7 health check. And what this allows a customer user is to define what is the acceptable loss, latency, and jitter for their applications. Once we determine that, then if we, at the end of the bucket, we will calculate if the SLA is met or violated. Then if the SLA is violated, if any of the metric exceeds the configured threshold, then we take the tracker down, and then the traffic will be not forwarded out of that tunnel. Likewise, it allows what is the mode of the SLA, and I'll talk about the mode shortly. And user can assign only one SLA profile for a specific SIG or SSE tunnel. You cannot configure like two profiles for a same tunnel. It has to be like one-on-one mapping from the SLA profile to the associating to the SIG tunnel. And now let's talk about the SLA mode. In this SLA mode, we have set it to be aggressive, which will be keeping the bucket size or the pole interval to 60 seconds, as shown in the slide. And these modes, if you are familiar with enhanced application aware routing, part of the 20.12 release that we had this feature, we are using the same intent-based modes, and these modes will define like how quickly the traffic will switch to a better path when the SLA is not met. Likewise, when we keep measuring the SLA, and let's say at some point we had seen that the tunnel is not experiencing any degradation, and all the measurements are going to meet the configured loss, latency, and jitter. It should be all the parameters. Like when we bring the tunnel out of SLA, if one of the SLA parameter is exceeded, we bring the tracker down. When we want to bring the tracker up or put the tunnel into forwarding, it has to match all the metrics like loss, latency, and jitter. So for us to say that the SLA is met, the loss should be less than 10% on this tunnel, and latency should be less than 400 milliseconds, and jitter should be less than 30 milliseconds. So, and it's kind of an and conditions. So all of these should be met. Now, once the SLA is met, now the decision to bring up the tracker state is made. A tracker is like if the tracker should come up or not is made. And we also account for dampening. So let's imagine a situation where your internet service provider, or like there is some issue in the internet bound access, and the tunnel is experiencing constant flaps. We don't want to end up in a situation where you take the tunnel out of SLA, and then once it starts to meet the SLA, you bring the tracker up and put the traffic back into the tunnel. What Because that could be like there is a constant flaps, and we don't want to do constant flip flops. So what we do is we use a dampening interval, and that dampening interval, we will decide what is the dampening window. So we have a dampening window. So let's say the dampening window is 60 seconds. Over that dampening window of 60 seconds, we will monitor the tunnel and for stabilities. And if we see that the tunnel is stable, that's when the tracker comes up and then the traffic is again forwarded out of that tunnel. So this is to avoid a situation where you have some constant degradation happening, and we don't want to react and cause other issues with respect to your applications. So that is enabled by default. And let's look at what are the modes that we support. As I said, these modes will define if, let's say, your traffic is going through a tunnel, and let's say your tunnel is out of SLA. Now, if you have a mode called aggressive, we'll be able to switch the traffic to a best performing tunnel in 60 seconds. And these are like we talked about, like the bucket is nothing but like number of seconds that to wait to bring it out of SLA. And then the dampening multiplier is, going to be defining the dampening window. How long do you wait for the tunnel to be, stable, that you monitor, and then again put the traffic back into forwarding. So the next mode is moderate. This would be giving you 120 seconds of pole interval. So now you have a large number of samples, but it takes a little longer. uh, and then like the final one is conservative. Again, you have a larger bucket interval, so you have larger samples, but then again you have to wait longer here. And these dampening multipliers are fixed in this release. We are going to support customizing these in the subsequent releases. There is a radar or roadmap to provide this custom SLA profile, so where you can fine tune these multipliers. These are the time intervals. Like I said, when you have aggressive mode, you have a dampening window of 60 seconds, which is basically the dampening multiplier times your pole interval. If you are using moderate, again, dampening multiplier times your pole interval, the dampening window becomes 240 seconds. Likewise, for conservative, it's again dampening multiplier times your pole interval, so it becomes 900 seconds. So to summarize, with enhanced app route tracker for L7 health check, this enhances the previous tracker, the traditional tracker with L7 health check that was only supporting latency. Now we are adding loss, latency, and jitter, and we are measuring this SLA, and user can configure this. And this is again up to the user or customer to decide what is the minimum acceptable SLA metrics, like what is the minimum loss, what's the minimum latency that they can define. And then they can configure this, and they can set the mode. And the mode, like I talked about in the previous slide, how fast you want to move the traffic to a best performing tunnel. So if you set it to be aggressive, then we will switch over the traffic. You have a better convergence. Again, user can also define these in a tracker profile and associate to a tunnel. As I said, you can only have one association of an SLA profile to a tunnel. And as a best practice, we do recommend that if you have 4 active tunnels, you configure the SLA profile. You need to ensure that the same SLA profile is tied to all these tunnels. The system will monitor for all the soft degradation issues on the tunnel, for packet conditions like transport is experiencing packet loss or latency or jitter, and then we'll be able to measure using this SLA profile. And if the tunnels do not meet SLA requirements, we consider all the three, and then the tracker is marked down, and then we can see that the traffic will not use that tunnel. SLA dampening is enabled also by default to consider the flap scenario that we discussed. It is providing us the best user experience. So some of the design consideration: an enhanced app route tracker for layer 7 health check is available for auto tunnels using secure internet gateway or secure services edge or Cisco secure access tunnels. And it is also supported for manual SIG tunnel workflow using the generic SIG provider. And again, like some of the best practices here is that when we have these probes sent out, we do need to have like a tracker defined, a layer 7 health check traffic defined, and then it's also that like let's say if you use like a custom tracker, so we provide a default tracker for these endpoints. So if it is an umbrella, there is a default endpoint that we use the probe, and if it is a zscaler, they provide us an endpoint that we probe. It is also possible to define custom trackers. However, we don't recommend to use like commonly visited websites, such as like google.com or like these common website, because whenever we see such kind of like probes coming all through this cloud security providers IP address space, then Google can issue like a captcha, and then they can blacklist this IP, right? So we don't want to end up into that situation. So configure the endpoint, and only HTTP endpoint is supported, and that's one other thing you need to be aware. So let's look at the configuration details here. Some of the config prerequisites, all the device versions should be 20.14 or 17.14, and this is going to be out soon in the market. And it is also recommended that all the SIG security internet gateway or SSE configs are already onboarded. So Cisco Secure Access, we started supporting that from 20.13 or 17.14. And so make sure that all that configuration is pre-done for enhanced app route tracker. And also like the default layer 7 tracker or custom layer 7 tracker, that endpoint that I talked about must be configured. And this is already supported today. It's so we need to make sure that that is there. And today the enhanced app route tracker for layer 7 health check, it only supports CLI add-on. If you're using configuration groups, there is a CLI profile, you can use that, and I'll show that in the demo as well. The tracker will start using the SLA profile parameters when it's configured. So even though you have this traditional layer 7 tracker, the moment you configure the SLA profile and associate to that tunnel, the tracker will start use these measurements. And then it will kind of override your layer 7 health check traditional support. So make sure that that is understood. This is the configuration snippet. I have an SLA profile, and this is just a name. So endpoint tracker SLA profile, you can give any name. And as I configured loss as 10% and latency as 400 milliseconds and jitter as 30 milliseconds. And then SLA mode to be aggressive. And again, on the top, you can see the custom tracker. Here I'm using google.com, and this is also a prerequisite, like I mentioned. And then once you have the SLA profile, you need to link that to the endpoint tracker. So this is how under the tunnel, you would specify the endpoint tracker SLA profile. And then this is what will start using the SLA metrics. And again, if you have like active and backup tunnel, the best practice is to configure the same SLA profile for both the tunnels. And as I said, you can only have one SLA profile associated to a given tunnel. And this is just an example like where I have my active tunnel on tunnel 15 million one, and then the backup tunnel is 15 million two. So this is how the config looks. And in the configuration groups, you can see how you can define this. When you configure everything else, if you want to use enhanced app route tracker, you can use a CLI parcel under the CLI configuration group profile, and then you can input the endpoint tracker, and you can give the tunnels, and you can also once you push the config, the tunnel that the manager assigned, and then you can use the same name, so that you can variabilize that, and then you can just give the same name, and the endpoint tracker SLA profile gets associated. And that's all you need to configure this capability. So let's look at some of the verification now. And so show endpoint tracker records, it's there. So this is the layer 7 auto tracker service.sig.umbrella.com. If you are using a default tracker, this is where the probes get destined to. In my case, I'm using custom tracker, which is to the google.com, and you can see all the trackers here. And then show endpoint tracker SLA profile is a new CLI that will give you what is the SLA profile and what is the mode currently used and what is the configured last. Once you have that, then you can see the endpoint tracker SLA status. This will show whether this tunnel 15 million 2 is meeting the SLA. If it is meeting the SLA, it will say as met, and then it will show what's the measured latency and jitter and loss currently. And again, you can also use endpoint tracker SLA statistics. That will also give you the same information. And this is another way to verify what is the measured loss, latency, and jitter. And as you can see, like my tunnel 15 million is down here, and that's the reason I only see the SLA status for one tunnel, which is 15 million 2. And if you do show endpoint tracker, you can see that tracker for the tunnel 15 million went down, because in my case it's a timeout because I physically shut down that interface. You can see that. And if you want to see the probes and the group of probes, you can see the probe ID from this output on tunnel 15 million 2. And then if you do show IP SLA group schedule 59, it will be showing you the probes to be scheduled. And you can see there are 12 probes that are to be scheduled. And if you do show IP SLA summary, it shows you the HTTP probes, what's the target destination, and what's the round trip time, and like for all these like individual probes. Now, if you want to look at the individual probe, show IP SLA configuration will show you like we are doing an HTTP ping to this target address, sourcing from this IP address, which is in VPN 65530 or VRF. And then this is the target source port, the target port, like we said, only HTTP is supported, and the custom tracker URL, google.com. So it gives you more details with this configuration as well. So what are the guidelines and limitations? Like as indicated before, only CLI add-on or parcel support. Custom SLA profile is not supported. It's on the radar or roadmap. And best of worst is not supported. What I mean by best of worst is, let's say you have 4 tunnels and all the 4 tunnels are out of SLA. And when all the tunnels are out of SLA, how do you want to forward the traffic? Do you want to use best of worst of based on loss, latency and jitter, or you want to use based on latency? So that is not supported. And again, it's on the radar. These are all the items that are on the radar or roadmap. So currently it's only through the monitoring of it is only through the CLI. Again, we are adding this support like as a radar for these items. So just so you know, these are current limitations or guidelines. So now it's the demo time. Let me quickly flash the topology here. And I have site 600 here, which is my branch site. And I have traffic coming from 10.6.100.60. It's going to the DIA, and I'm just going to issue a traffic to the just 8.8.8. And then I will I will see that initially the traffic was going through the tunnel 15 million 1, which is my active tunnel, and then this is my backup tunnel, and then I'll add a latent loss of 12% on this interface, and then we will see the traffic going to the the backup tunnel when we see the degradation, and then we will remove the loss. So these are the steps that we will do. So first, the traffic goes over the tunnel 15 million one from site 600. We'll introduce 12% loss on the tunnel, and then we will see that the traffic will switch over to the tunnel 15 million 2. And as a step 4, we will remove the loss on the tunnel 15 million 1. And this time, the traffic will still be using tunnel 15 million 2 because the dampening kicks in and it waits for the dampening window. And once we see that there are no flaps and then the tracker comes up, and then the traffic will move to the primary tunnel 15 million 1. So with that, let me show you my manager to see how to configure this, and then we will show the demo. So let me stop sharing my other window here. Okay. Okay. So let me. I think this is 20.14 release on SD-WAN Manager, and you can see that currently, if you go to the security here, um, let me 1 second. Uh, Let me just connect to my VPN because I connected to a different network because of my internet issues. Okay, let me reshare my screen here. Okay. Yeah, so this is my manager with 20.4 version here, and you can see it's a live system here. So it's running the EFT code. So this is not generally available yet. And you can see all my devices here. So I have three validators or vBonds and two controllers or vSmart and manager. And then if you look at my current tunnels, here you can see all the list of SD-WAN tunnels and the SIG tunnels. So for the demo, I'll be focusing on site 600. So on this site 600, I have two tunnels to the umbrella data center. So my active tunnel is tunnel 15 million 1, and my backup is 15 million 2. And right now you can see we can also get the tunnel status, and you can see if the tracker is enabled or not. And then I do have like other tunnels which are towards like using Cisco Secure Access or SSE, and these are the tunnels to those from site 700, and I have a site 200 where I have Zscaler, secure internet gateway tunnel, and then you can see the status of it. And you can also see like quickly look at the events on the tracker state changes, and you can see like the visibility of those. There is no currently the SLA profile, that one is still not shown, but you can see the when there is a tracker state change, you can see that through this. And so this is all there for the for the traditional. So now let me go to the let me go, yeah, you can also go here if you want to see the logs. So this is another way to see your logs. So you can see in like what are the tracker state changes, and what's the host name and the system IP and the tracker name. So I have a custom tracker. So this was the alarm you can see. And you can also go to the overview here, and you can go to you can look at like the security from here as well. So in case, like, let's say you want to see what is configured right now. So right now I'm using configuration groups and policy groups, which are part of the SD-WAN UX 2.0. So if you see right now, I have a policy group created, and and I'll come to this. I'll show you the security internet gateway, or SSE policy, that I've created. So if you go to the security internet gateway here, or SSC, you can see all the policies. So for site 600, let me show you and what I have. So I have the tracker source interface. So I have an umbrella SIG provider, and then the source IP. This is what gets used in VPN 65530 for probing the HTTP endpoint. And I am using a custom tracker, and you can see I have custom tracker to the Google destination, and I've modified some of these and just these are this is configured, and this is prerequisite. And then you can see that I have two tunnels. IPsec 1 going out of gig 5 is my primary, and then IPsec 2 is my secondary. So I have like an HA pair, my active tunnel and backup tunnel, and this is how you would set up your policy. And once you do that, then you would come and define a policy group, and then you would select that policy here, and then you would associate to a device. So in my case, you can see it's associated to site 600, and, uh, and then once you associate, then you can deploy. So I have already, like, I can go and redeploy. I've already deployed this, but this is how you would go and deploy. And you can see what are, like, if you make some changes, you can see that in here. And this is part of our existing UX workflow. So again, you can review the config and deploy. So I have already deployed that, and I'm just showing you the workflow now. So once you define that, then you can look at like, again, go back here, and then you can go to the device, and then you can look at the tracker commands. So I've done that. So let me start showing you also, like, the yeah let me start showing you the topology one more time, so that you know what is happening. So let me share. Yeah, so right now, this site 600, I have two tunnels to the SIG umbrella, and then you can see this. And then let me show you like what I have in terms of the traffic. So let's say I have the two tunnels set up. Now I have associated that to the device, and policy group is associated to the device, and you can see that. Now I want to show you the part of the configuration that is for the SLA profile, the new configuration. So under feature profiles, if you're using UX 2.0, there is a CLI add-on profile, and here you can define the new configuration that you want to push. So this is the new configuration. So I have pre-provisioned the previous configuration, and now I'm using a CLI add-on template, CLI add-on profile, and then I'm giving the new CLI, and then this will be getting associated to the endpoint tracker. So I have SLA profile, gold SLA, and then I'm pushing this through the CLI. So this is how you would do to push the new configuration through CLI profile. If you are using device templates, there is a CLI add-on templates, and you can use that as well. But for this demo, I'm just using everything on the UX 2.0. And now once you have that, then you can basically come to the device, and then you can see that right now you have the tracker status, and then two trackers. And right now the tracker status for tunnel 15 million 2 is down, And if you look at SLA status in here, and you can see there is a high jitter on this tunnel, and that's why the SLA is not met. Okay. So again, so what I will do is I will go through the sequence of steps here. So I have my traffic running from 10.6.100.60, the site 600, to 8.8.8. And you can see now the traffic is going over tunnel 15 million one. And if you look at the flows, you can see that the traffic is coming on gig 2 and going out to tunnel 15 million one, and the return traffic is also coming back on the same tunnel. And you can see the stats, you can see the packet count increasing. And this is where I am introducing loss for this. So I'm now adding the loss of 12%. So this command introduces the loss on the tunnel 15 million one. So now what should happen is the traffic will, you'll see the SLA, not violated on that tunnel 15 million one. It should show as not met. And right now you can see the SLA profile. These are the commands and the SLA mode. So these are the modes we talked about: aggressive, moderate, conservative, and these are the CLIs that show what's the dampening window as well. So now let's look at the statistics to look at the current loss, latency, and jitter. And now once we have enough samples, and now we can see that the loss spiked up after we added 12% loss. We are seeing the loss as 33% now here. And now you will see that the tracker will say as violated or not met. Now, if you look at the tracker, it goes down. So now the traffic will not use the tunnel 15 million one. So if you also look at the flows currently, you will see that the traffic will switch over to tunnel 15 million too. So you can see traffic coming from the service VPN. It's put on now 15 million too, and the return traffic also is coming from 15 million too. So this is the part one. So now what I'll do is go back to the slides here to show where we are. Uh, so we introduced step two, loss of 12%, and step three, we see the traffic switched over to the tunnel 15 million two. And now I'm going to remove the loss, which is step four on this task. So let's go ahead and remove the loss. And this is the CLI command that would remove the loss on the link. And once you do that, you would now see that now the dampening window will kick in, because you can see the traffic still uses tunnel 15 million too because of the dampening. And now once we know that, for the dampening window time, we monitor and we saw that the tunnel was stable. So we wait for that time. So the traffic will still use tunnel 15 million too, as you can see. So once we see that the dampening, like you can see the traffic is still flowing through, and that once you have that dampening window done, then you will see that the traffic will move back to the active tunnel. So now we monitor for the dampening time, and we saw that we moved the tracker to up. So now the tunnel 15 million one will be put back into forwarding. So that is what the dampening is doing. Yeah, now we can see if you look at the traffic flow, again it will move back to the active tunnel 15 million one here. So that this kind of confirms how the enhanced app route tracker is tracking the SLA and moving the traffic to the best performing tunnel. So hope that was useful. And so what we did in step five is, once we removed the loss, the dampening kicked in, and then we wait for the dampening window duration. And Once we know that the tunnel is stable, then the tracker comes up and then the traffic will be switched back into the tunnel 15 million mark. So that concludes the demo part. And here are some of the references on this capability, what is needed to enable this capability, what are the config prerequisites. And once we have this release posted, we will have the more documentation on this enhanced approach tracker. So with that, I would like to thank you all, and I apologize for the initial glitch on the internet. I think I was able to, cover all the material after that. And then thank you all for chiming in. And with that, I would like to conclude this session.
Awesome.
Over to you, Carlo.
Thank you very much, Karthik, and very informative. I do have a couple questions coming in, so if you do have a question for our speaker, please feel free to send it through the question and answer panel. First question I have here, Karthik, is are these tracker probes sent over the tunnels or are they using an underlay?
Yeah, that's a good question. So the tracker probes are sent over the tunnel, and these are not sent via the underlay path, and it is using like these are sent over the tunnel to the endpoint. And again,
Okay,
make sure like you know that the tunnel is up, but it's in a degraded state, and that is how we are able to send these probes.
awesome. Thank you very much. All right, moving on to our next question. Is SLA applied to tunnel down scenarios or hard failures?
Okay. The SLA is applied only to the soft failures with the transport degradation issues such as packet loss, latency, and jitter. So if the tunnel is down or there is a hard failure, then the SLA is not applied to that one. So this is only for a scenario where you have transport conditions and the transport is degraded. The tunnel stays up, but it's in a degraded state, and then we use the SLA to monitor the loss, latency, and jitter.
Awesome. Thank you very much for that. I do have another question that came in. Let's see here. Is do we establish a maximum number of tunnels that can be deactivated because of SLA breaches to prevent a complete outage?
Yeah, currently I think what we support is we support like I think we increase the support now. I think it is 16 tunnels, so you can have 8 active tunnels and 8 backup tunnels. And in a scenario like, yeah, you can use the maximum number of tunnels as well. Like, and with Cisco Secure Access as well, we increase the support of the throughput as well to 1 gig.
Awesome. Good to hear. All right. And this one came in um, mid your during your presentation. They were wondering if the Cisco Secure Access is that supported or is it only Umbrella and Zscaler IPsec?
Cisco Secure Access is supported starting 20.13 or 17.13 release onwards, and currently it is supported. Yes, and this capability that we're talking about comes after 20.13, which is 20.14. So Cisco Secure Access is supported, and if you look at if you basically take a look here, and like you can. You can also like I've shown you in my demo as well, where I had where I had the secure access as well. And if you look at here, like you can see under security dashboard. So this is where the SecOps view that I was talking about. So you can see that I have SIG or SSE tunnels, and if I click on all these tunnels, and it takes me to this, and on site 700 I do have Cisco Secure Access, and so it is supported, and this is this is 20.14. So yeah, so you can see that, and if I show you my site 700 device here, so if you see show SSE all, and so I have two tunnels towards tunnel 16 million 1 and 2, towards the Cisco Secure Access. And if you look at this box as well, I have SLA profile associated, and and then you can see that yeah, it is calculating the SLA for these tunnels as well. So long story short, it is supported. Yeah.
Awesome. And then this one came in as well too early on. It says, I'm guessing what you explained is just for C edges. V edge isn't supported. Is that correct?
That's correct. Yeah.
Awesome. Let me go ahead and mark that down. Next question is, what is the MTU used for the probes?
Yeah, so the probes, we are just again like there is no change with the HTTP samples. So we are using the same that we supported since 20.6, and the exact MTU. I mean, like it's a HTTP packet. So again, like it's just going the HTTP ping to that target destination. And the exact MTU, I can get back on that one. But again, just keep in mind that the HTTP probe mechanism keeps like it's the same mechanism as in starting from 20.6 release. So there shouldn't be any changes as per as MTU is concerned.
Awesome. And then leading on to that, can I use iOS XE packet trace tool to pick up those probes?
You want to look at those probes using the packet trace. So is that the question, if I understood correctly?
Yes, that's what the user confirmed.
Oh, okay. So again, let me check on that one. Is this regarding to like more on the troubleshooting that you're looking for this information? If yes, again, I can get back to you on that.
Uh, he said yes regarding troubleshooting, so
Yeah,
he'll
I
get
think
back
it
to
should be technically possible. Again, if there is any concern, please do reach out to me, and we'll certainly work with you. So I can drop in my email address. Just drop me a note. It should be technically supported. I don't see a reason why. Again, like I haven't done that myself, so I can also confirm with my peers. But do let me know if you see any concern with that.
you. Awesome. And then one last
Yeah, like
question.
it is
Oh,
just
sorry, go ahead.
going over that it's going over that VPN 65530, and that's where the probes are sourced off of that loopback interface that we create in 65530. So you should be able to capture that using packet trace. Again, do let me know if you see any concern. Yeah.
Thank you. And then one last question is there in the roadmap to make the latency time dynamic so that network admins do not have to calculate RTT per tunnel and base my SLA configs on that? So I can just configure RTT X3 or X4 as an example.
Okay, so that one again, like it's not, it's not currently supported today. Again, certainly take that as a feedback, and then we could also look at and then try to see if we can improve that and get it supported. But currently, it's not supported.
Awesome. Thank you. And I think that does it for us today. Is there anything else you'd like to say before we wrap up, Karthik?
I think thanks all for chiming in. Again, this is going to be part of 20.14, 17.14. We have got tremendous feedback from the customers, from the EFT early field trials, and we have received a positive feedback. So go try it out and reach out to us in case you need any support from us, and reach and if you need if you have a valid business case and you would like to see more improvements, reach out to me so I can work with you all. Thank you.
Awesome. Thank you very much, Karthik, the whole team for bringing your knowledge to the Cisco community. Again, if you have a question, I do encourage you to take a look at the post-event discussion link that's in the chat. For even more tutorials, demonstrations, and future webinars, please do visit that link. At this time, your feedback is important and you'll be directed to a survey, so we do encourage you to take the time to participate. Let us know how we did and any future topics. Once again, we thank everyone for joining us today, and we will see you next time. Have a good day.